Hello, I'm Corey Ryland, and today I'm talking about RxJS and Observables and how they apply to Angular 2. So to start off, what is an observable? An observable is a new primitive that's coming to JavaScript that helps handle our asynchronous events and data in our applications. You can kind of think of them like promises, but more advanced. Observables can handle more than one request. So a promise can handle one event and return a success or error, whereas an observable can handle multiple events over a given period of time. So let's start with a promise, and let's just work through and see how an observable is very similar to promises. So first, we're going to go ahead and just create a promise. And our promise here returns our resolve object. And we're going to just do a set timeout and make this asynchronous. And we'll set it for about 2 seconds. And we'll console log. Now we will work on our promise, and we will call then and get our value. So our promise will wait 2 seconds and then emit promise timeout, and we'll console log that to the browser. So if we refresh, wait 2 seconds, and we get our promise timeout. So now let's see the exact same thing, but with an observable instead. So observables, you can kind of think of them as streams of events. And a common pattern when creating an observable is to set the observable to end with a $sign. This just lets the reader know that this object here is an observable in a stream of events. So we're going to create our new observable here, which emits an observer, which is similar to our resolve from our promise. So now our observer will call a next method, and that will emit our value. We want to wrap this in a timeout. And we'll do that for 2-second delay as well. So now that we have our observable created, it will wait for 2 seconds and then emit our observable timeout message. Now, what observables do is they subscribe to these events. Very similar to then, instead of calling then, we will call subscribe. So we'll have our stream1.subscribe, and it'll emit our value. We will console log value. So not too much different than our promise here. Main keywords that are different, instead of then, we have subscribe, and we have next instead of our resolve. So if we refresh, we should see 2 messages. And we do. So observables are at least as powerful as promises. So what can observables do that a promise can't do? Well, if we think about observables as values over time, we can emit those values in sequence. One of the other benefits is observables are cancelable. Once a promise fires off, that promise can no longer be canceled. It has to return a value back. And this could be an issue on features such as type aheads, where you have to call out to the server and emit AJAX calls. We would like to cancel those if the user starts typing again, and that's not possible with promises. But with promises, or with observables, we can cancel those out. So let's try to cancel out our new observable here. So we're going to set our timeout here. An observable returns a function, and this function is called whenever the observable is unsubscribed. Once all the subscribers unsubscribe from it, this function is called, and it allows us to clean up after our observable. So we're going to call clear timeout and clean up our timeout once we are done. Now, we subscribe to this observable. Now let's unsubscribe to it. So when we subscribe, we get a disposable back. This disposable is what lets us unsubscribe. Now if we save, what we're going to do, we're actually going to wrap this in a set timeout. We're going to delay this 1 second. We're going to see how this behavior works. Our observable, once we subscribe, will wait 2 seconds and emit our value. But we are going to unsubscribe after 1 second. And we'll see how that affects the behavior of our observable. So you can see we got the promise timeout, but our observable was canceled before it was able to emit that next value. And this is a really important feature that we'll see later on. So going back to our example of talking about streams, observables, you can think of observables as an array of values over time. So we're going to create a new observable. It's going to give us an observer. And in this example, we're going to create an interval and create a counter. And it's going to call it every 1 second. And we'll set our return function, which will clean up and end our interval once everyone unsubscribes from it. Now let's subscribe to this observable. And see what it looks like. As you can see, our observable can emit multiple values over a given time, completely asynchronous. And this is something a promise cannot do. And you can think of this as our array. And since this is an array over time, we could actually use array-like functions on this observable. And in the library RxJS, this library implements a number of utility functions called operators. These operators is what really gives our observables a lot of power in our applications. So our first example, let's filter on our observable. And we want to filter out any values emitted that are even, or filter out the ones that are odd. We only want the even values. And then we're going to subscribe to this. So if we refresh, now we can filter out only the values we want. We only want the even values. And this can be described with a technique called RxMarbles. This is a way to describe our behavior of our observable. So on our observable, we emitted new value every second. And then we call our filter operator. And that filter filtered out our values for us. So on the other side, we only get 2, 4, and 6. You can see demos of this on rxmarbles.com. It's a really good site to see behavior for observables and how they work. So now let's look at another operator. I'm going to use the map operator. And our map operator maps over each value over the given time and multiplies by itself, emitting the new value. And this can be described in the same sense as our filter with our Rx marbles. We had emit 1, 2, 3, and 4. After our map, we get 1, 4, 9, and 16. So as you can see, our observable is a lot like a promise, but we can handle multiple values over time. Then we can stream this data into our application and use these operators to filter and manipulate the values as they come into the stream. So let's come up with a more practical use case. So we are going to make a counter with observables. It's going to have an increment and decrement button, and it'll just display on the UI the new value. So we're going to make buttons. Now that we have our values, we're going to create new observable streams from these button clicks. Now, RxJS comes with multiple different operators out of the box that let us hook into native DOM events really easily. We're going to create a new stream, increment clicks. We'll use the operator from event. And we pass in our element and the event we want to listen to. We'll do the same for decrement. Now we have two streams for our clicks. So let's try subscribing to one of these. As you can see, our observable is now bound to this click event, and now we have a stream of click events. One common thing to forget about is our users' interactions are asynchronous themselves. So we can treat their interactions as observable streams just like we could with timeouts or asynchronous AJAX calls. So since we have two different streams, what we'd really like is one stream of clicks. And using more of the Rx operators, we can merge these two streams together to form an outputted single stream. So then, once we merge these into a single stream, we're going to map over each click event and get the button's value out. And now we have a stream of click events that return each value that was clicked from our buttons. So another stream can be made to track the total of these emitted values over time. So what we'll do is we'll create a total stream. And use the scan operator. The scan operator, similar to the reduce operator in RxJS, except it doesn't have to wait until the observable finishes. It'll emit a new value as they come in. So we'll total up our values. Now that we have a stream of total values that are coming from our click events, we can simply subscribe to this. We'll just set our counter our text to our value. So to go over this again, we have two different click streams. We merge them together into one single observable and then map over each value and make that our integer value, our number of -1 or +1. And then we scan through all the given values and total them up and emit the total value. So now we just simply subscribe to our total observable and it will emit the new total every time a button is clicked. So if everything worked correctly, we should see some new values. And we do. So we can increment and decrement. And what's really nice about this is there's no state tracking through this. Our data through the user events just simply flow through our observables, and we use our operators to manage that data. And this is really nice because the code is very simple and easy to test. And we can dig into this a little deeper. We can use a Rx marble diagram to kind of think about what really just happened here. So what was our first step? We emit a value. We'll emit one increment. And then we'll emit two decrements. So if we refresh, it'll be 1 and then -2. So our total value is -1. So +1 and then -2. So now we called a merge on these two streams. So our merge essentially takes these values, makes them a single stream. This just makes it easier to manage. Now, after we merged, remember we mapped over these values, and we mapped over them because when we get the value from the button from the DOM, it's a string, and we have to map over that and make those numbers. So we get a positive value and 2 negatives. Then once we have our stream of events, we use the scan operator to go over our values and then total them up for us as values are emitted, with our final value of -1. You can see everything is one stream, and then using our operators, we transform that data down until we get the value that we really want. So next, I'm going to go over how observables and RxJS plays into Angular 2. So Angular 2 and the Angular 2 team have adopted observables throughout the entire framework and is very observable heavy. So I have a simple Angular app here. And what we're going to do is we're going to build a type ahead search feature to hit YouTube's API. And the requirements of this feature is we would like, as the user types in the input box, to search the YouTube API and pull in results. But there's a couple key things. We don't want that API to be hit after every key up. We need to be able to throttle those events as we go and wait until the user has finished typing before we call out to the API. Another request we would like is to be able to cancel the previous API calls if the user starts typing again. So let's look at our app. We have our constructor. We just have a couple of consts here, our API URL and our key, and then our search form. And this is just a simple Angular search form with one control, a search input, and it's a required validator. So let's look at the template for this. So we have our simple form here, our search form with our one control of search, and that is all. And then once we get back our results, we're going to loop through them with ng4 and display that data. We'll come back to this in a minute. So what does Angular use observables for? Well, there's a handful of different things built in that are observable based. The first and most common one is the new HTTP service. The new HTTP service is actually observable based and returns an observable instead of a promise. And there's a few advantages to this that we'll see in a few. Another key feature that is observable based is our forms. In Angular 2, our forms can actually be observed. So let's go ahead and start with that. We have a search input here, and really what we would like is to subscribe to this search input. And as the value changes, to be notified so we can handle the request. So what we're going to do is we're going to go ahead and make a new stream of results here. As you can see, we have our observable defined. And we can directly observe to this from our search form. So on our search form, we have controls.search, and then there's an extra property here called value changes. And this actually an observable that we can subscribe to. So let's go ahead and subscribe to this. And let's go ahead and refresh our app here. need to comment this out. Not ready for that part. And we subscribe to our input, and as you can see, as I type, new values are emitted through our observable. So our next step is we don't want to subscribe to this. What we really want is we want to call our API. So we're going to use an operator called switch map. And this is similar to map. And if you've heard of flat map, it's similar to that as well. And basically, when we call our Angular HTTP service, it's going to return an observable. So by the end of this operator, what we'll end up having is an observable of observables. And what we'll really want is to flatten that out as we go along. So let's go ahead and add our API. So our HTTP here actually returns an observable. And what we'll want is this switch map will actually map through all the requests. And the really cool part is if a request, a value is emitted from our observable, it will actually cancel out the previous observables. And this is a really cool feature. As the user types and we hit the API and call out to XHR for XHR calls, every time a new value is emitted, this will automatically cancel the previous value. And this is really helpful for freeing up resources in the browser because it cancels out those network requests and the browser doesn't have to handle them anymore. This is really important on mobile devices or constrained devices. So then we'll need to do a couple small things real quick. We'll need to map over our responses because we'll want to get the JSON value out of it. And then just by the nature of YouTube's API, we want the list of items that are returned from the API. So if we look at this one more time, we have an observable from our Angular form that emits a new value every time a key up value changes on our form, specifically our search input. Our switch map will call our Angular HTTP service every time a value changes and cancel any previous values, observables that are emitted early on from the user typing. After that, we map over our responses to get the JSON, and then we emit the items from the API that we get back. So if everything went well, let's refresh. And actually, we need to uncomment our template here. If you noticed, our property on our component is actually an observable. And a really cool feature of Angular 2 is we can bind our templates directly to an observable using this new async pipe. And this is really neat because the template can bind directly to the observable. And then once the template is done or our component is destroyed, it will clean up and call the observable done events and clean up any extra tasks that need to be done. So just a quick look at our template. We just loop through the results. We display the link, title, description, and the thumbnail of the YouTube result. If we save everything, and we're going to refresh, and we got our results. Search Angular, and we get all of our API results. Now there's some interesting bits to notice. If we look in the network tab here, and clear this back out. Watch as I type what happens to our XHR requests. As you can see, as I type, we are canceling our previous XHR requests, which is pretty nice. We can free up those events from the browser. But there's one thing that we're actually missing. As you can see, it's canceling and emitting much faster than what I can type. So we need to actually add a little bit of a delay, even if we are canceling the XHRs. And that's actually pretty easy with RxJS. Right before our switch map, we're going to use an operator called debounce time. This simply delays or debounces our observable from emitting the value. So we're going to wait 500 milliseconds before emitting to our switch map. Now we go back and refresh. Now, if you noticed, there was a 500 millisecond delay before it actually calls our API. Which is really cool. Now we have a search feature that uses the on events of our input to easily search this API with very little code. If we look at our observable here, we were able to implement this feature in technically a really one line of code, just using RxJS and these operators. So that's a brief overview of RxJS and Angular 2. Hopefully that was informative, and let me know in the feedback if you have any ideas or any good feedback for me. Thanks.